Welcome back to Adam 411, where we always discuss anything meaningful. Okay, I just want to say this. I got two guys here, Donald Hoffman and Nassim Haramein, and they have a very, very interesting view on reality, on the objective view of reality. And I'm just interested on what you guys think about it. What does anybody else think about this? What's your view? What's your take? Because what I see here is I see two really interesting ideas that are opposing to each other. And the reason for that is their interpretation of the double-slit experiment. And I know they don't talk about it. And that's fine. I mean, actually, one of them does. No, Nassim in this one does end up talking about it if you watch the full video. But and I think it's that reason that's the crutch for me, the deciding factor on where they diverge. Because the way you interpret the double-slit experiment can really change everything on top of that. And it's not necessarily just the double-slit experiment. It's just your interpretation of quantum mechanics. And so, I mean, the double-slit's the core of what a lot of the arguments are. So I love both these guys. They're really, really great scientists. They've spent many, many years dedicated to their field, putting in the work. So let's go ahead and dive right in.
It's a really important thing for people to have a realization about the nature of reality. Our body, the biology all around us have a common cause. There is a fundamental field at the source of creation. I've been working on unifying all this for 35 years, from the scales of the cosmology to the scales of quantum mechanics, which currently is fractured in our physics. And that's a big problem. If you access this, all of a sudden you realize the infinite nature of your existence, the incredible potential that you hold. We've called intuition as almost a derogatory word, where in fact intuition is the most valuable. It's like the universe is talking to you, and are you listening? There's a really bright future for humanity if we are able to bring this level of information out.
That. All right, now let's get to know Donald.
We have assumed in science for hundreds of years that space-time is fundamental reality. In the last 10 years, for the first time, scientists have taken off the space-time headset. What are we going to find? So I should be very, very clear on this point. Now, I'm a cognitive neuroscientist, and when I say that space-time isn't fundamental and objects in space-time aren't fundamental, that means neurons don't exist when they're not perceived. What I'm saying is very, very uncomfortable that we don't see reality as it is. This theory of conscious agents is really the first layer of software outside of our space-time headset. Once you know the software, you can change the game pretty much any way you want to.
So you believe we're living in a simulation of sorts?
I think that we just have to bite the bullet and say, no matter how smart and mathematically precise you are, it's going to be trivial compared to the reality beyond. And I think as a scientist, it's critical for me to actually spend time in utter silence. That's where the true new creativity comes from. What we know is one perspective out of an infinite number of perspectives. But that's who you are. What you are transcends any description. And that's how the infinite comes to know itself.
Great. Hey, shout out real quick to Know Thyself, Andre the Queen. He's really good. And he's got great content. You can check him out. Here's the channel here. All right. That was both of their intros, and they're pretty good, right? I mean, it's really interesting, the things that they're talking about. You don't hear it every day. It's not mainstream science. It's just, but it's something about it, that it feels like maybe one or both of them are on the right track somehow. I don't know. It's really cool. Anyways, I have an idea. Ship over here to ChatGPT. On this first one here, I just said, please explain the view of Nassim Haramein, okay? Nassim Haramein is a controversial figure known for his alternative theories that merge physics, cosmology, and ancient history. His ideas challenge mainstream science, and he presents an interconnected view of the universe. Here's a summary of some key ideas. Unified field theory and the geometry of the universe. Harmein's core theory is based on a unified field concept which seeks to explain the fundamental forces of the universe: gravity, electromagnetism, the strong force, the weak force, within a single framework. His work revolves around the idea that space is not empty but filled with energy and structured at all scales through a geometric pattern. He proposes a model where the universe has a fractal and a holographic structure. At the center of his model is the Schwarzschild proton, a concept he introduced that treats the proton as a mini black hole, postulating that protons interact through gravitational forces, not just the strong nuclear force. Haramein argues that toroidal geometry, a donut-like shape, is a fundamental to the structure of space-time, and that everything from the subatomic scale to the galactic scale follows this geometry. He integrates this into his idea of the connected universe, where all matter and energy are linked. The role of black holes. Haramein has a distinctive view on black holes, suggesting that they are present at all scales, from atomic nuclei to the center of galaxies. He argues that black holes are the organizing principle behind matter, proposing that everything in the universe is connected through a black hole dynamic, including humans and other life forms. Including humans and other forms of life. He has a particular emphasis on the concept of a vacuum that contains almost infinite energy. According to him, black holes draw energy from the vacuum, and the universe as a whole is a dynamic system where black holes play a central role in the creation and interaction of matter and energy. 3. This is some interesting stuff, but it doesn't pertain to what we're talking about today, so we're going to leave that out. But this one, 4. Criticism of mainstream physics. Haramein is critical of modern scientific paradigms, particularly those related to quantum mechanics and general relativity. He suggests that mainstream physics has limitations due to its inability to reconcile gravity with the other fundamental forces. He aims to address this through his unified field theory. While Haramein's theories are met with interest by some, they are widely criticized by the mainstream scientific community. Physicists often point out that his work lacks rigorous mathematical foundations and does not align with established scientific evidence. The Resonance Academy. She promoted his ideas. We don't need to know that either. And then we have what scientific papers has Nassim produced. These are the papers that he's produced, and you can go ahead and pause it if you want to. I'm not going to read all the papers. He's co-authored and authored these papers here, and you can go and read them or look at them, and he's got other videos and whatnot. Alright, now let's take a look at Donald. Please explain the view of Donald Hoffman. Donald Hoffman is a cognitive scientist and philosopher known for his interface theory of perception and his views on consciousness, reality, and perception. His work challenges traditional ideas about how we perceive the world. Here's a breakdown of his key ideas. 1. Perception as an interface. Hoffman argues that our perception of reality is not an accurate reflection of the world as it is, but rather a simplified user interface. He compares this to a desktop on a computer screen. Just as the icons on your computer don't show the internal workings of the computer, our perceptions don't show the true nature of reality. The desktop metaphor suggests that evolution shaped our perception to help us survive, not to reveal objective truth. Fitness beats truth, Hoffman suggests. That natural selection favors perceptions that are useful for survival rather than those that are truthful. Our brains evolved to prioritize practical utility over accurate perception. The world we see, therefore, a simplified version shaped by evolutionary fitness, not a detailed replica of objective reality. 2. Conscious realm. Hoffman also put forward the idea of conscious realms, which proposes that consciousness is the fundamental nature of reality. According to this view, instead of material objects being the basic building blocks of the universe, consciousness itself is primary. Physical reality as we experience it is a product of conscious agents interacting with each other, rather than something that exists independently of our minds. Conscious agents in this model, conscious agents are the building blocks of reality. Hoffman posits that these agents experience, perceive, and interact with one another, giving rise to the complex structure of what we call reality. Physical objects emerge from the interaction of these conscious agents rather than existing independently of perception. 3. The problem with physicalism. Hoffman critiques the traditional physicalist approach to science, which assumes that consciousness arises from physical processes in the brain. He argues that this view is fundamentally flawed because it cannot explain how subjective experiences, qualia, arise from physical matter, the hard problem of consciousness. Hoffman's theory aligns with the view that the hard problem of consciousness, which is how and why physical processes give rise to subject experiences, cannot be solved by materialist explanation alone. Instead, he suggests flipping the paradigm. Consciousness doesn't arise from matter. Matter arises from consciousness. 4. Mathematics of consciousness. Hoffman has also proposed a formal mathematical framework for describing conscious agents and their interactions. This model seeks to represent how different agents perceive and influence one another, and how their perceptions combine to form the experience of a shared reality. 5. Virtual reality metaphor. Hoffman often uses the metaphor of virtual reality to describe how we experience the world. He suggests that our sensory experiences are akin to the interface of a virtual reality system. While we might think we're interacting with real objects, what we experience is a highly constructed version of reality tailored to our needs as organisms, similar to how virtual reality creates convincing but illusionary environments. Conclusion. Donald Hoffman's view radically rethinks perception, consciousness, and reality. His idea suggests that what we see and experience is a simplified interface designed for survival, not a reflection of objective reality. Consciousness is fundamental, and the physical world arises from the interaction of conscious agents rather than the other way around. Perception is akin to a virtual reality, and science may need to move beyond physicalism to fully explain consciousness and reality. This perspective challenges conventional scientific and philosophical approaches, offering a new way to think about the mind and the nature of existence. And here is the scientific papers from Donald Hoffman. I said, what scientific papers has Donald Hoffman produced? Just like I did with Nassim. And just like I did with Nassim, I am not going to read all this either. But you can see he has authored and co-authored and been a part of many, many, many things. Yeah? Okay, great. Now we've seen who they are a little bit. We got a rough overview of their ideas. Let's jump into some more stuff that they say that I think is kind of interesting. Let's get into it.
I think it's a really important thing for people to have a realization about the nature of reality, like that coherence and self-organizing systems that we are in, our body, the biology all around us, the structure even of solar systems and galaxies and all this have a common cause, that there's a fundamental field at the source of creation that's producing all the effects we see at the physical level and the biological level. and to unify all this from the scales of the cosmology to the scales of quantum mechanics, which currently is fractured in our physics. And that's a big problem. So I've been working on unifying all this for 35 years, and there's technological applications that come out of it that are really transformative for society. A new way of extracting energy, a new way of dealing with gravity, and so on. So there's a lot, to unpack there. If we do it like really naively, the holographic principle appears when you're counting the number of grains in the volume of the proton, and you find that it's equivalent in terms of energy or information as all the other protons in the universe, so that each proton contains the whole, which is a principle. It's a principle of holography. But let's start from the beginning. When Max Planck started quantum mechanics, he did so because he was given the task to make a better light bulb. And the light bulbs at the time were burning out too fast. And he was asked if he could help to make a better one. He was a famous physicist. People thought he could help. And he looked at the theories of the time, and they predicted something goofy about the emission of thermodynamic emission, or the electromagnetic emission of a heating body. It said that the emissions should have infinite amount of ultraviolet. It was called the ultraviolet catastrophe. And when we were measuring the ultraviolet of a light bulb in the laboratory, we weren't saying infinite amount of ultraviolet. So Planck thought, okay, how can I fix this equation? And in fixing it, he added like a fudge factor. Okay, he called H, a constant that became Planck's constant. And basically, your listener needs to know a little bit of quantum mechanics. Basically, these equations are describing an oscillator, a harmonic oscillator, which is usually represented as a spring with a weight. But the universe doesn't do springs and weights. I mean, it does after it's made the human that makes the spring and the weight. So it's really kind of a bad visual to use, although it's the visual that's taught to students typically when they're learning quantum mechanics. The oscillator is best visualized as a little spinning top, right? That's oscillating. And it's absorbing photons and emitting photons, right? So he described like the little heat that's coming off the filament of the light as like oscillators, and the constant he put in there, like eventually, like imagine you're describing the atom as a little oscillator, right? And the constant that he put in there to make it work so it give the right answer on the spectra of light that comes off the filament, it predicted something weird. It predicted all the correct values for the different temperatures, having different colors of the spectra, right? Which is the Planck's law. But and it got rid of the infinities for the ultraviolet, but it predicted something more than that. It predicted that they would be, at 0 Kelvin when there's no thermal agitation, there should be no energy. But what the equation predicted is that there's an infinite amount of energy at 0 Kelvin. And so Planck called it 0-point energy. And that's and so basically it said something really weird as well. It said that the constant he added, called H, and then eventually H bar, meant that the oscillator doesn't continuously emit electromagnetic field like thermal radiation, but it does so in packets. of energy. So it builds energy and then it releases a packet. It builds, or it only absorbs packets. You understand? And so it was saying something that was not instinctive to him, that like there would be packets, and eventually Einstein took these packets, called them photons, and described the photoelectric effect, which he won the Nobel Prize for. So these packets or quanta of energy started quantum mechanics. And as I was saying, the equation on top of it said something weird about the foundation or the ground state of the electromagnetic field. Instead of saying that at 0 Kelvin, when everything is frozen and the little oscillator should be frozen and nothing is happening, it should have 0 energy. Instead, it said it had infinite amount of energy, like that there was a bath of infinite amount of energy at the ground state of the electromagnetic field. And so in the paper we just published, we start with that because actually this history of 0-point energy is not necessarily well thought and well understood by the scientific community. And the fact that mathematically you cannot remove the 0-point energy is not necessarily well understood neither, because in history what we did is we removed that ground state because they didn't know what to do with an infinite amount of energy. They didn't like that answer, so and it's not clear. It was the time of the war. People were racing to make the atomic bomb. Maybe it was removed on purpose, because maybe we didn't want certain countries to have an idea that there's infinite amount of energy available, and they were trying to create fission at the time and so on of the nuclei of the atom. Maybe that was removed on purpose, but anyway, it was removed. And we showed that makes quantum mechanic mathematically inconsistent. Technically, it makes the equation commutative when it should be non-commutative. That is, the little oscillator is absorbing photons and emitting photons, right? By removing the 0-point energy, it's like you remove the source of energy. If we go back to the spring, if you stop doing this, the spring is going to stop oscillating, right? It has to have a source. So when you remove the 0-point energy, it's like you remove the source of the oscillator. You still can do math on the oscillator and get the right answer and all this, but now the oscillator physically is missing the source of energy to make it oscillate. You understand?
Kind of.
Yeah, like your car wheel is like an oscillator, right? It's spinning, but you have to put energy in the motor for the wheel to turn.
Mm-hmm.
If you remove the energy, right, you could still do the math of a wheel turning as if it didn't need energy, but in the real world, it does, right? So all the oscillators that makes up the atoms, like the atoms being these little oscillators that are absorbing photons and emitting photons, well, they wouldn't be able to continue if they didn't have this source of energy in these equations. And to remove it is inappropriate. So we demonstrate that initially. And then we eventually show that that source of energy is actually the source of mass for the atom.
Go ahead and jump over to Donald Hoffman, though, and get some insight from him.
So Darwin's theory is very clear that evolution shapes sensory systems to guide adaptive behavior. And that's true. According to Darwin's theory, that is in fact true. Most of us think intuitively that to do that, evolution must shape us to see the truth, because clearly, if you see the truth, that will be much more adaptive than if you don't see the truth. So to guide adaptive behavior, evolution must also shape us to see the truth. And it turns out that that extra assumption, which isn't in Darwin's theory, shouldn't be in Darwin's theory. Now, the mathematics of it is very, very simple. The payoff functions that guide evolution. Like if you play a game, you have payoffs. If you make certain moves on the board game or in a video game, you get certain number of points, and if you get enough points, you can get to the next level of the game. If you don't get enough points in time, you die, so forth. Same thing like in evolution. There's the evolutionary game theory. You have payoffs that guide adaptive evolution. And what happens with those payoffs, they're basically not telling you whether you go to the next level of the game, but whether your genes, your offspring, go to the next level of the game. So when you analyze those fitness payoffs and ask, do those fitness payoffs contain information about the true structure of objective reality? Right? If they're going to shape you, if the payoff functions that guide evolution are going to shape your sensory systems for you to see the truth, then they have to know a little bit about the truth themselves, or they can't shape you. And what we've proven, and this is again work with not just me, but Chetan Prakash and Manish Singh, Robert Prentner, and Brian Marion and Justin Marks, so a number of other people, not just me. What we've shown is in a number of ways that the payoff functions basically don't have the information, almost surely don't have the information about the structure of the world. So you can actually prove the probability is precisely zero that any payoff function has that information, and therefore it's precisely zero probability that we've been shaped to see reality as it is.
All right. Thank you for joining me on that journey. Wow, that was a pretty cool video. Both of them. I wish I could get into more with these guys because they have some very interesting ideas. I have a couple other guys that I can't wait to get into either. But thank you for joining me. Just thank you for sticking it out. I'm sure this was a long video. I'm just getting into this. So if you liked the video, please put a thumbs up. Subscribe, leave a comment, anything helps. It really does. I'd really, really appreciate it. Thank you for joining me. My name is Adam, and I hope to see you next time.